Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the fourth lecture of this ongoing online course on understanding and reducing greenhouse gas emissions with the focus on scope 1 and 2 emission reduction through building design and construction. I am your instructor, Professor Avlokita Agrawal. I am an associate professor at Department of Architecture and Planning, IIT Roorkee. Now, quickly giving you a recap of what we have done so far. In the first week of this course and the first 3 lectures of this week also, we have been seeing historically how we have started to discuss the issues and why we have kind of centered on this point that we need to reduce the consumption and combustion of the fossil fuels, and we have to reduce the, not in absolute terms as in reduce beyond a certain benchmark, but we have to limit the emissions of greenhouse gases. So, that is what has become central to the UNFCCC Kyoto Protocol, which has now moved on to be known as Paris Agreement, which is the successor to Kyoto Protocol. So, essentially what we are trying to do is we are trying to reduce the greenhouse gas emissions. We will gradually move on to GHG protocol, greenhouse gas protocol, where we will know what scope 1, 2 and 3 of emissions are and how do we reduce them. But before we do that, the first thing, since we have been almost for 1.5 weeks, we have been talking about greenhouse gases and reducing the greenhouse gas emissions. So, it is fundamental for us to understand what are greenhouse gases, and that is what we are going to know in this particular lecture. So, what we have done so far, I have quickly explained to you that it has been a historical perspective which has led us to this point where we talk about reduction of greenhouse gas emissions. In this particular lecture, we are going to talk about greenhouse effect, characteristics of greenhouse gases, their concentrations in the atmosphere and their impacts on greenhouse effect. So, let us begin with this lecture today with understanding greenhouse effect. Now, what greenhouse effect is? One, we have to understand that it is actually a natural phenomena which today is strengthened by anthropogenic activities, man-made activities, but greenhouse effect is where certain gases or elements present in the atmosphere, they absorb the radiation coming from the sun, the solar radiation, which is actually a short wave radiation, and they hold the heat, they absorb the heat and they retain this heat in the atmosphere. And since earth has an atmosphere and it has the greenhouse gas effect, that is why life has been possible on earth. So, greenhouse gas effect is not negative, it is not a bad thing, that we have to clearly know. Life on earth is possible only because of this atmosphere and greenhouse effect. If it was not there, if there was no greenhouse effect, then earth must have been an ice ball. The average temperature of earth would have been minus 18 degrees centigrade, and we would rarely have had different plants, flora and fauna species and food on earth. A lot of things would not have been possible. We would not have been the lively planet as we are today. So, what happens as far as greenhouse effect is concerned in a natural environment is that the sun's radiation, which is a short wave radiation, it travels to the surface of earth, and while it is traveling, so a part of it is actually reflected by the atmosphere, about half, and part of it is absorbed by these clouds, and some of it is reaching the surface of earth, which is then absorbed by oceans, land, the flora on earth. Now, the energy that has reached, the radiation that has reached the surface, it will also be reflected back. So, the part which is reaching the surface of earth will also be reflected back, part of it, and some part of it will be absorbed by the surface. So, it will be absorbed, and after that it will be re-radiated back. So, when it is re-radiated back, at that time also some of it will escape to the space, to the outer space, while the rest of it will actually be absorbed by clouds by gases, so by the atmosphere, and this phenomena is known as greenhouse effect. Now, the problem is that we have an enhanced greenhouse effect, and why do we have that? Because there is more and more concentration of greenhouse gases in the atmosphere. So, to certain degree, to certain extent, greenhouse effect is essential for our own survival, for having a lively planet on earth. But what has happened? So, this is naturally what happens here in the greenhouse effect, as I have explained. But what is happening now is that this factor, which is the greenhouse gases and more humidity, more cloud formation, when that increases, more and more of the heat is absorbed in this layer, and this is the enhanced greenhouse effect that we are talking about. What that implies is that more radiation coming from the sun is now trapped in the atmosphere. It is not able to leave, escape into the outer space, and hence we have this phenomena which we have known, which we have discussed so far as global warming. And global warming is the central phenomena which is causing a lot of climate change to happen. Weather pattern is changing, extreme climatic events are happening, and we know that our seasons, our weather patterns, winds, storms, rains, almost everything is actually driven by the energy that we receive from the sun. That is one of the most significant factors. And now the energy that is received from the sun is trapped, it is imbalanced. It was supposed to leave, almost 50% of it was supposed to leave the planet Earth, but it is now getting trapped in the atmosphere itself, and hence a lot of these impacts that we have seen because of climate change, and the root cause of it being trapping of the greenhouse gases there. So, this is what is happening when we are talking about enhanced greenhouse effect. So, what are these greenhouse gases which are causing the greenhouse effect to happen? So, majorly the greenhouse gases, they have been categorized into these 5 major categories. One, no category as per the nomenclature, but it is one single gas, and this is the most significant contributor to greenhouse effect, which is carbon dioxide. All of us know that. And then we have methane, which is CH4. So, that is also single gas, but next to carbon dioxide, it is the second most significant contributor to greenhouse effect. Then we have nitrous oxides. So, we have different NOx. Then we have water vapor, H2O, which is present in the atmosphere, and we have fluorinated gases where fluorine compounds are there. We also have there are varieties, there are different varieties of fluorinated gases. We have chlorofluorocarbons, hydrochlorofluorocarbons, CFCs and HCFCs, which not just create the greenhouse gas effect, but they also have the potential to deplete ozone layer. So, these are the different major categories of greenhouse gases that we are concerned with, and we will look at how and from where these different gases will be generated. Now, fluorinated gases in general, they are found in refrigeration systems, air conditioning systems, heat pumps, and as you all must be aware, you are aware that the changing lifestyles across the world have made us more and more dependent on air conditioning systems, on refrigeration systems and heat pumps. Earlier, we were not using these systems to provide for comfort inside the buildings, but now we are actually doing this. We are depending more and more on these systems, which implies that we are using more and more of fluorinated gases. Now, the source for different gases, we have quickly seen that fluorinated gases, where are they emitted, and let us quickly go through the sources of these emissions of different gases. So, if you look at carbon dioxide, very clearly we know that carbon dioxide comes from burning of fossil fuels. Now, burning of this could be from various sources. It could be for transportation, for industrial processes, for cooking, for heating, for generating energy, electricity. It could be for anything, but primarily whenever the fossil fuels are burnt, we will be releasing carbon dioxide and we will also be releasing methane sometimes. Then nitrous oxide, and then another reason for this is deforestation. So, when a tree is cut, it has already stored a lot of carbon inside it, and when the tree is cut and it decays, it releases this carbon. As it oxidizes, it releases the carbon dioxide, and that is also a major source of emission of carbon dioxide. And how do we remove it? Photosynthesis. So, photosynthesis, as all of us have studied right from school, it takes up carbon dioxide and it converts it into different forms of energy, say food and oxygen. It gives back oxygen. So, it disintegrates it. So, that is what photosynthesis does, and that implies that we need to plant more and more trees if you want to remove gases like carbon dioxide. Oceans, as we have talked in earlier slides also, earlier lectures also, that oceans also absorb a lot of carbon dioxide, because there is different flora and fauna, which is able to capture this carbon dioxide. So, forests and oceans are the two most significant removal sources. They sequester the carbon naturally. Then second greenhouse gas is nitrous oxide, and that is released when we burn fossil fuels, when we burn the biomass. So, the biomass which has not fossilized, that burning of that will also release nitrous oxide, and also through use of fertilizers. Majority of the fertilizers are nitrogen based, and when we use them and when they interact with the soil and the plant, that is the process in which nitrous oxide is released. And how do we remove it? We can remove it by soil, and if you have understood the process, the nitrogen cycle, there with the help of certain roots of certain plants, they help in fixing the nitrogen in the soil. So, if you have gone through the nitrogen cycle, you will again see that plantation of certain specific crops and plants, a variety of plants, again we are talking about plantation, responsible sustainable agriculture here, that will help us in removing the nitrous oxide from the atmosphere. Also, photolysis in stratosphere is one source for removing nitrous oxide, but we do not have much control over this, but we surely can have control over this part, where we can promote sustainable agriculture, and we can also promote planting of more and more forests, which will help in fixing the nitrogen, taking it away, taking it out from the atmosphere. Then we come to methane here, CH4, again burning of biomass, agriculture, combustion of agriculture, and fermentation, the process of fermentation, all of these they release methane. Now, how is methane? So, most of these except for burning of biomass could be considered as natural processes. Of course, anthropogenic activities might increase them. One major thing that is happening is because of global warming, which is already happening, a lot of these glaciers are melting, a lot of ice caps are melting, and they are releasing, they are allowing the grasslands to be exposed. Now, all that biomass which is there is decayed, and when it is exposed, it releases the decay of that has already kind of oxidized the biomass. The decay has already released the methane, and which was then earlier trapped because of global warming, it is now being released into the atmosphere. That is a natural process. So, it is a vicious cycle. So, the more global warming increases, the more grassland, the ice caps and the grassland covered under those ice caps, they will be exposed to the atmosphere, and more methane is also getting released. So, this is what is also one of the major source of emission of methane. And how can we reduce it? How can we remove it? By certain microorganisms, they uptake it. So, algae for example, it uptakes the methane and then it fixes it, but when it decays further, it will release the methane again. So, that is what we are talking about here. And the last one is fluorinated gases. It is largely emitted through different industrial processes. So, industries are the major contributor to fluorinated gases, and what we can do is we can do photolysis, and its reaction with oxygen is what removes fluorinated gases, and it is difficult to remove it. That is why in the first place we have to reduce the the production of fluorinated gases. So, if we look at this, what we can clearly see that gases like carbon dioxide and nitrous oxide, they can be emitted easily by burning of fossil fuels and burning of biomass, but the removal is also easier through maintaining forests and oceans. That is what we can do. But as far as fluorinated gases is concerned, they are produced through industrial processes and it is difficult to remove them also. So, we have to go steps ahead and we have to have industrialized processes for removing the fluorinated gases also. So, naturally it is difficult to remove the fluorinated gases. So, in the first place we have to work towards reduction of emission here itself, while for carbon dioxide and nitrous oxide we can also look at the sequestration strategies. So, we have to have a balance of both these strategies, one cutting down on emissions and two sequestering whatever has been emitted. So, there has to be this balance, and if you remember when we were talking about Kyoto Protocol, we were actually talking about this. So, sequestration mechanisms, the green projects, the emission reduction projects could also mean developing projects where we are talking about sequestering some of these greenhouse gases. Now, if we look at the concentrations in the atmosphere, so from 1990 to 2015, if you look at this graph, you will see that the concentrations have only been increasing, and proportionally if we will see, proportionally the individual concentrations of carbon dioxide, methane, nitrous oxide and the fluoride gases, they have all remained pretty much constant. If we compare with the overall number, but their absolute values have been increasing. So, if we consider this as 100, then proportionally the carbon dioxide still remains at close to 80%. But if we look at the absolute number, this absolute number has moved from around being 22.5 to close to 35 here, 33.5 here. So, there has been a constant absolute increase in the number, but proportionally it has remained the same. So, what we are seeing, and this is a small duration of just 25 years that we are considering here, when we will see the graph for hundreds and thousands of years, we will see that the concentrations have increased tremendously after industrial revolution. So, this is what is happening, and these are the concentrations that we are talking about. So, while carbon dioxide, and we will see that it is the gas which can be one of the greenhouse gases which can be managed most easily. So, we can manage it easily because the sequestration process is simple. You just have to plant trees, more and more trees be planted and we will be able to remove carbon dioxide, and the same is with nitrous oxide, that we plant more and more trees and plants which can fix the nitrogen in the soil. So, it is not that much of a problem if we are also looking at the sequestration side. If we look at the sectors, greenhouse gas emissions by sectors, so who is responsible? We have already seen the sources from where each of these gases will be emitted. So, we have to clearly see that energy is the biggest culprit, and our lives are becoming more and more dependent on energy. So, when we say that we have to reduce greenhouse gas emissions, we are very clearly talking about reducing our energy consumption. And unfortunately, while we talk day and night about reducing greenhouse gas emissions and reducing the consumption of energy, our per capita energy consumption across the world is only increasing. Developed worlds have very high per capita energy consumption, literally they are totally dependent upon energy. Thankfully, in the less developed, in the developing countries, the per capita consumption of energy is lesser, but the other side of the story is that these countries are also one of the most populous countries. For example, if we look at per capita energy consumption of all the countries, we have the data and we compare the numbers. US is probably the highest, per capita energy consumption in US is the highest in the world, and India is very low, very less per energy per capita consumption is there in India. But if we look at the absolute numbers, because India is a populous country, one of the most populated countries in the world, and we multiply this number, the per capita energy consumption, by the total population, we get a really huge number which surpasses the total energy consumption of the United States probably, or comes at par. So, that is the problem, but the base of the problem remains that our energy consumption is only increasing, and this is what we can see. So, energy consumption is increasing and the emissions from energy consumption are also increasing. What can we do? We have to switch to cleaner fuels. We have to switch to alternative sources of energy. So, from burning conventional fuels to generate energy and electricity, we have to shift to solar, wind, hydro. So, nuclear, which have lesser emissions. This is what we have to do. So, energy, as you can see, is the prime contributor to greenhouse gas emissions, and after that, if you see, agriculture is the next. Now, if you remember the land use changes, when we were discussing the land use change map, there built up area was a very small sector, but the larger area of the land was actually covered by the grazing lands, the crops for feeding animals, farms for meat and dairy. That is plus agriculture. We also have large areas on earth for agriculture, and if we are not engaging in sustainable agriculture, which traditionally all ancient civilizations did, traditionally across the world we were carrying out with sustainable agriculture practices, we have gradually, almost the entire world has departed from the sustainable agricultural practices, and that is why we will see that agriculture becomes the second major contributor to greenhouse gas emissions, which is unfortunate. And we have practices, we have a know-how of practices. We have to become conscious and shift back to the sustainable practices, organic farming, the natural processes of farming, which will reduce the energy emission, the greenhouse gas emissions and their dependence on energy. Other factors are industrial processes, which is third. So, we might be thinking that it is the culprit. It is not the culprit, but I will come to the actual numbers, because agriculture and energy production, which are, so energy uses fossil fuels, it burns and it releases a lot of carbon dioxide into the atmosphere, but it is a huge portion. Industries consume this energy. So, we have separated energy, but industries actually consume this energy. So, directly the emissions which are happening because of industries due to their use of energy is not counted for energy, but when we say emissions due to industrial processes, we are actually looking at a serious problem, because we have fluorinated gases being released from the industrial processes, and that is a worrisome part. We will gradually come to this in this lecture itself. And then we have another growing problem, which is of waste. We know there is so much of plastic waste and a lot of different types of waste, which takes hundreds and thousands of years to fully decompose, and in that process of decomposing, because we are not recycling it, we are not decomposing it in a scientific manner, a lot of the waste across the world, as we have seen, is either dumped in the oceans or it is dumped on the land, and then it contaminates the land and water and also air. It releases a lot of gases. So, methane, the dump yards, the waste yards are responsible for emission of methane significantly. So, waste is another problem, another major source of greenhouse gas emissions. And then we have smaller factors such as land use change and forestry. As we said that whenever we undertake deforestation, we are releasing carbon dioxide in the atmosphere, we are releasing methane in the atmosphere. So, land use changes and forestry, this is another cause for emissions, and also international transport, the aviation. We have already seen that Paris Agreement does not include civil aviation into the consideration for reducing greenhouse gas emissions, but if we look at the sources of greenhouse gas emissions, we clearly see that international transport, which is aviation, it is one of the significant contributors. Now, this number, this bar might be looking very small, but if you look at the absolute numbers, this is a significant number that we are looking at. Now, so this is sector wise contribution to greenhouse gas emissions that we have seen, and we have already seen the different gases, how they are present in the atmosphere. Quickly looking at the global atmospheric concentrations of different gases over time. Now, here we are looking at starting from 8 lakh years of Earth's existence, and here we have come to 0, this is 0 CE, and suddenly you see this streak. So, we are talking about 8 lakh years here, and in that duration the carbon dioxide concentrations, they have just fluctuated. it's gone up and down, but in a very small bandwidth, not much, and suddenly it is not coming down, it is only going up, and this is just 2000 years. We are in 2023 here, and we are talking about it in just 2000 years compared to 8 lakh years here, and suddenly the concentrations have just doubled from the peak of 8 lakh years. That is what we are talking about, and it is not coming down, it is just going up and up. And that clearly tells us that we need to reduce the greenhouse gas emissions, and if we blow it up here, this is how we have moved. So, this is all after industrial revolution, and the world is only industrializing more and more. Our dependence on energy, our dependence on machines, our dependence on gadgets is only increasing, and thereby the emissions here. So, this is for carbon dioxide. If we look at methane, it is exactly the same story, probably more alarming. So, from 500 here, which was probably the peak for 8 lakh years, we are closing in on 2000. 4 times concentrations of methane is what we are talking about, and this is the blow up here. Same with nitrous oxide. So, where we were 300 max, we have gone up to 350, and if we look at different selected halogenated gases and other ozone depleting substances, after Montreal Protocol we have actually worked hard. So, for example, you will see this particular gas is methyl chloroform, and we have reduced the concentrations in the atmosphere, and as I said, we have also seen the effects of that, because more than the global warming potential, we will come to what global warming potential is. The ozone depleting potential of these ozone depleting substances was more, and hence their reduction. So, for majority of them, either they have been contained at the same level or their concentrations have been reducing. So, this has impacted the health of the ozone layer there, but overall if we see the concentrations of the global concentrations of greenhouse gases, they have been increasing, and they have increased in the last 2000 years only, and in that 2000 years also it has increased after 1800s when industrial revolution took place. So, that is the seriousness of the issue that we are talking about, that we need to reduce greenhouse gases emissions. If we look at the atmospheric concentrations of ozone, so it dipped initially. So, here we are starting from 1980s, but it has pretty much been maintained, and we have gained back the complete layer is what we are talking about. Now, if we look at the levels which we have just seen in the graphs, you can see the same numbers from starting from 280, we've almost doubled. Methane, we've increased significantly, nitrous oxide and other tropospheric ozone. So, they've slightly increased, and this is what we are looking at. But one thing that we are looking at is the radiative forcing. So, before I tell you what is this radiative forcing, you can also see that there has been an increase in the radiative forcing. Now, we will come to the to understanding that what this radiative forcing is, and quickly looking at these chlorofluorocarbons. So, there are these different chlorofluorocarbons and how their concentrations have been. So, we also have a lot of increase in the concentrations of these chlorofluorocarbons and subsequently an increase in their radiative forcing. What is radiative forcing? So, radiative forcing is the amount of heat that one molecule of that gas can hold as compared to the amount of heat that one molecule of carbon dioxide can hold. So, if there is one molecule of carbon dioxide and it can hold x amount of heat, it has been equated to 1 unit of heat that can be radiation that can be stored by a molecule of carbon dioxide, and for example, one molecule of methane can hold 84 times the heat of as compared to carbon dioxide molecule. This is what we are talking about, the radiative forcing, but at the same time there is another factor which impacts this radiative forcing, which is the atmospheric lifetime. So, some molecules, they will be staying in the atmosphere for a shorter span, while some of them will be staying in the atmosphere for a longer time. So, if there is a molecule with higher radiative forcing and also a higher atmospheric lifetime, that will have a greater potential for global warming as compared to a molecule, a gas which has lesser radiative effect and shorter atmospheric lifetime. So, what is atmospheric lifetime? Atmospheric lifetime is the time required to restore equilibrium following a sudden increase or decrease in its concentration in the atmosphere. So, if there is a release of certain gas, suddenly there has been a release of certain gas, certain component in the atmosphere, how much time will be required to bring it back to the equilibrium, the actual concentration that is supposed to be, is its atmospheric lifetime. Now, if we look at the different greenhouse gases, we will have different atmospheric timelines. So, water vapor has an atmospheric lifetime of about 9 days, but if we look at the lifetimes of other gases, which we will come to in another slide here, there are gases which may take many years and as high as thousands of years, and when I say thousands of years, it is like 40,000 years, 50,000 years of a lifetime to leave the atmosphere or to regain the equilibrium. That is the lifespan that we are talking about. Carbon dioxide, we consider its atmospheric lifetime to be 1, and we compare everything with that lifetime and with that radiative forcing. So, radiative forcing, it is quantified in watts per square meter. It quantifies the effect of factors that influence Earth's energy balance, and that includes changes in the concentrations of greenhouse gases. So, greenhouse gas effect or radiative forcing is required to certain extent, but when it becomes excessive, that is when the problem starts, and that is what we are dealing with today. Now, together when they are brought, the radiative forcing and atmospheric lifetime, so that is what gives us the global warming potential. So, it depends upon the efficiency of molecule as a greenhouse gas and also its atmospheric lifetime. So, as I said, the global warming potential is measured relative to one molecule of carbon dioxide. So, all other gases, they have been measured with carbon dioxide as being the benchmark as one unit. And as I had said earlier also, carbon dioxide as a gas has the least global warming potential, and all other gases that we have seen and we will see, they have a much higher global warming potential. So, if you look at this, here we have carbon dioxide and its global warming potential for a 20-year period is 1, 100-year period and 500 period is also 1, where we are looking at its lifetime in years, and we are looking at its radiative efficiency or radiative forcing. So, this is the number which you can see for carbon dioxide. And now, if we look at methane. So, if you look at a 20-year period, the global warming potential of methane for a 20-year period is 83, but its GWP for 100-year and a 500 period is reduced. Why? Because its lifetime is less, it is 12 years approximately. So, if we look at this, for a 20-year period, it will have a higher global warming potential, but when we look at a 100-year period or a 500-year period, because it would have already removed or it would have come to a state of equilibrium within that period, that is why its GWP for a 100-year or a 500 period will be lesser. Now, if you look at the chlorofluorocarbons or hydrochlorofluorocarbons, which is this band, we will see that they have a lifetime going up to 100 years too. So, plus they have a radiative efficiency which is much higher as compared to the base, which is carbon dioxide. Here we are looking at 1.37 multiplied by 10 to the power minus 5 times. So, this is watts per meter square, and here we are looking at this number which is approximately 0.3. We are looking at multiple times the number that we have for carbon dioxide as far as its radiative efficiency is concerned, and a lifetime which is also almost 50 times higher than that and that is why you will see this number in comparison to 1 GWP of carbon dioxide, we will see that chlorofluorocarbons have a way higher value. So, this is starting from minimum 2600 and going up to almost 11,000 as compared to 1 GWP of carbon dioxide. They have a higher lifespan. So, higher is the lifespan, but when we are talking about 100 and 500 years. So, since their lifetime in years is still at max 100 years for most of the chlorofluorocarbons and hydrochlorofluorocarbons, we will see that this number will reduce significantly when we are talking about the 500 years lifetime. But come to the fluoromethanes and the fluoride gases here. This is alarming. This is significant. Look at their lifetime in years. We are talking about minimum of 500 years and a maximum of 50,000 years of a lifetime, atmospheric lifetime for certain gases such as tetrafluoromethane. So, we are talking about fluoride gases, and these are majority of the industrial processes and the refrigeration and air conditioning that we are using, where all these gases are going. So, they have now, and you also compare. So, this is their radiative efficiency is slightly lower than the chlorofluorocarbons, but their lifetime is so high that if we look at the GWP for a 20-year period, it is significantly higher. It suddenly increases very high, and it does not decrease over a 500 period because its lifetime is 50,000 years. So, it continues to increase in a 100-year period and also in a 500-year period. So, unlike the chlorofluorocarbons, where we saw that it is reducing over from 20-year period to a 500 period year period for global warming potential, here most of the fluoride gases, their potential GWP potential will continue to increase over a 500 period. Now, the nitrogen trifluoride, which has a lifetime of 500 years, there also, so the increase is slightly lesser, but still there is an increase. So, you can clearly see that this is one group of gases where the GWP over 20 years to 500 years period is very high, and it only goes on increasing because their lifetime is very high, though their radiative efficiency is slightly lower than chlorofluorocarbons and hydrochlorofluorocarbons. So, this is one group of gases. This is another group of gases that we are talking about, chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs. Their 20-year GWP is high because their lifetime is less than 100. So, their GWP for 20-year period is high and it gradually decreases over a 500 period GWP, but they still have a high overall. If we compare with carbon dioxide especially, they have a higher GWP. And then we have three gases where we have carbon dioxide, methane and nitrous oxide. All these three gases, methane has two sources, fossils and non-fossils. As I said, fossil burning also releases methane, and biomass burning and decomposition of biomass also releases methane. So, we get a lot of methane from wastelands. So, there are two different sources and they have the same potential, but so this is what we are talking about. We have a very low GWP, and here also, as I said, that it is possible to sequester these three gases naturally. So, we can sequester them by maintaining health of our forests, our oceans, planting more plants and crops which fix the nitrogen. So, these three can be managed. Now, what that clearly implies to us is that we have to reduce our dependence on air conditioning and refrigeration, heating, heat pumps. We have to reduce our dependence on that. And how do we do that? We design better buildings, we design better homes. Just think of it, remember, go back to your the land use changes that we were talking about. We have such small built area compared to the total land mass that we have on earth, and that small built up area is where all the buildings of earth are concentrated, and those buildings only and infrastructure. So, that is all within that small land area. If we were looking at the land use, they are responsible for all of the CFC and HCFC production, because that is where all the air conditioning, heating, refrigeration is going. So, what we have to do? We have to reduce our dependence on HVAC, heating, ventilation and air conditioning plus refrigeration here, and we can do that by making buildings which are passively designed, which are passively heated and cooled. We will come back to this part of the scope and we will know clearly that greenhouse gas protocol has defined scopes where we can reduce the energy which is going into the buildings which is being consumed by the buildings and the emissions that result thereby. So, we have to reduce our dependence on HVAC if we want to reduce the CFCs and HCFCs, and for all the fluorides we have to reduce the industrialization processes. That is what our second intent should be. So, that is actually the third scope of greenhouse gas emissions protocol. So, what we are mainly looking at is that this entire potential, and if we look at the overall concentration, if I can show you this graph again. So, if we look at this particular graph here, a lot of carbon dioxide and methane and also nitrous oxide to some extent, a large part of it is actually getting produced because of the consumption of energy and maintaining the indoor environmental comfort inside the buildings. So, that is something that we can reduce and we will be able to reduce a significant part of greenhouse gas emissions is what we are talking about here. So, that is all in this particular lecture. I hope we have clearly understood that what these greenhouse gases are and what we need to do to reduce the greenhouse gas emissions through this particular chart, where we clearly know our direction, what all needs to be done. Clear instructions or clear deliverables we have in our mind. One, we have to reduce the consumption of energy in all forms. Two, we have to reduce the requirement for HVAC in our buildings significantly, so that we do not require refrigeration, heating and air conditioning in our buildings. So, that is the second part. And third, we reduce our dependence on industrialized products, manufactured goods. We depend more and more on nature procured goods and the manual production of things. Of course, the moment we talk about some of these agendas, we also have to see the sustainable development side of it. So, we can't do it in absolute numbers, but we can surely move forward in this direction. So, thank you very much for being with me in this lecture. We will continue the discussion in the next lecture with the understanding and calculation of carbon footprint. So, here we were talking about greenhouse gases and emissions. In the next lecture, the last lecture of this week, we will be talking about carbon footprint and how do you calculate it. So, this is only about greenhouse gases and global warming potential. There we will be talking about the carbon footprint, related terminology, related understanding, but slightly different. So, thank you very much for being with me. See you again tomorrow for the last lecture of this week. Thank you.